Okay, we're going to continue on with the regular polygon examples, but when we made this packet, we hadn't quite gone into the mode of doing online school for the rest of the year. So there's a couple of problems that we're not going to do, and then a couple of problems that we're going to change a little bit. So you should be here on the notes. We are going to do this problem here. So this, I'm going to label this exactly what it is. So this is given a radius. Okay, so we're going to do a problem where you're given a radius and you have to find the area. This one is also given a radius right here, given a radius. So that problem is just a second example of when you're given a radius. So those are two that are going to be essential. Okay, and then this circle problem here, we're actually not going to do that. We would have done that had we been meeting face-to-face, but that's something we decided to cut out. The same thing for these polygons down here. I will offer up a video for those if you're interested. It's like interesting information, but it's really non-essential. But if you turn the page, there are 3 more at the top of the next page. Same thing for this one. We're not going to worry about that one. It's kind of an extension problem. Here's another given radius problem. Okay, that I will kind of have you, again, pause the video and then you can kind of see if you're on the right track for that one. So this is another given the radius. And then over here, this is the last example we'll do. This is given an apothem. So those are the 4 that I'm going to do during this video. So again, 3 of them are the same, so it's up to you how much or how little of that you watch and practice, but then you'll have an idea. You'll at least have examples of each type, and then I'm going to actually show you on the last given the radius one, we're going to change that one a little bit. So if you are going to skip, make sure you skip ahead to the very end. You watch that little piece before you jump over to the homework, okay? Okay, so we're actually going to start with this one, given an apothem. I'm going to zoom in so you can really see what's going on here. So we worked on the video for the 11.3, the first video, we worked on if you were given the side length, okay? And every time you were given the side length, you had to find the apothem and then do the area of the one triangle. We are still going to do the area of this one triangle here. It's just that this time I know my apothem is 10 and you have to find the half of the side length. Okay. Step 1 is still always to find the angle measure at the center. So to find this angle measure here, we're going to do 360. We're going to divide it by, this thing has 6 sides. It's a hexagon, so divide it by 6. And then I'll take that answer, okay, which is 72. I'll take that answer and divide it by 2 so that I get just this half. Okay. Okay, so that answer is 30 degrees. Sorry, it's 60 for the whole thing and then 30 degrees. So if you take 360 divided by 6, that's 60. 60 divided by 2 is 30. Sorry about that. So 30 degrees is what we're going to write here. 30 degrees. You are still going to use tangent, which is what we used before. So we're still going to go tan of 30 equals, and then it's going to be opposite over apothem, or adjacent. So opposite of x, of 30 degrees, is x, and the apothem is 10. So it's going to set up like this time. So when I type that into my calculator, I'm no longer dividing, I'm multiplying, because I'm cross multiplying. So this time, the only difference is the setup of the sine, cosine, tangent piece, the trig piece. So we're going to take 10 times the tangent of 30, which is 5.77. Okay, so now we go back to the formula that we were using on 11.3 day 1, which is half of the side length times the apothem times the number of sides. Okay, half the side length is this number that you just got. So that 5.77 is half of your side length. So we'll take 5.77 times the apothem, which is 10, and then we'll multiply that by the number of sides, which is 6, because this is a hexagon. Okay, so I'll take my 5.77 times 10 times 6, and I get 346.4. And because it's area, it would be units squared, but there's so much for us to worry about on these problems that we're kind of not worrying about the labels because none of the numbers are labeled. Okay, so now let's talk about these given a radius problems. Okay, this one is going to be the easiest for us to draw and manipulate later. That's why we're going to save it to the end. So if you find this problem pretty easy, you can skip the second example, but definitely watch that last example because this is the only time you're going to see it. Okay, so same idea. We have this triangle and we're trying to find the area of the triangle. Right, so all of that is the same. Let's go ahead and find the angle first because that's the number one thing you should do in all of these problems is find the angle measure. So this has 1, 2, 3, 4, 5, 6, 7, 8 sides. So that's going to be 360 divided by 8, which is 45. But I'm going to cut that 45 degrees in half so that I can find my apothem. So that's going to be 22.5. Okay, so this angle up here and this angle over here is 22.5. Now, just to be clear, this radius over here is 20, which means this radius over here is also 20. Okay, so this is given a radius of the octagon in this case. And so both radii are the same length. So if this is 20, that's 20. It doesn't matter which of the two triangles we use. Okay, here's what we need to find. You're given that radius is 20, and you need to find this piece, which is half the side length, and you need to find that piece. So how are you going to do that? If I do tangent of 22.5, be tangent 22.5 equals x over a. I don't have any numbers. I can't actually do that. Well, that's because on this one, you can't do x and a at the same time. You have to pick one. Okay, so let's pretend for a second that a isn't there. A is gone. So from the 22.5, x would be the opposite, and 20 would be the hypotenuse. Which function deals with opposite and hypotenuse? That's going to be sine. So I have to do a sine to find x. Now we have to pretend that x doesn't belong, and we'll do a. A is adjacent and hypotenuse, so that's going to be cosine. So to find a, I'm going to do a cosine Okay, that is how I would recommend to set it up every single time. I understand that there are different ways to do it. If you found x using the sine, you could put x right here, and then you could use a Pythagorean theorem. You could put x here and then use tangent and x to find a. But this is going to work every single time. It's pretty quick to type it into your calculator and get your two answers, and then you can kind of move on. So I would recommend it doing this way, but just know that it's not the only way, and maybe some of your friends from other classes might be doing it a little bit different. And it's okay if you do it different. It's just when I show an example, I'm going to be doing it this way. Okay, so in my calculator, I'm going to be multiplying 20 times the sine of 22.5. 20 times sine 22.5. Okay, so this answer, x, I got 7.65. Okay, and then for the cosine, same thing, 20 times the cosine of 22.5, which is 18.48. Okay, and it might seem odd that the apothem is so much bigger than half the side length, but if you look at the triangle, it kind of does make sense that the apothem should be bigger. Okay, so again, the formula is half of the side length, which is x, times your apothem, times the number of sides. So half your side length is this 7.65. We're going to multiply that times your apothem, and then multiply that times the number of sides. Okay? Again, when you go to take the quiz on this, it is very important that you show this work. Okay? Because this is a problem that there's probably only going to be 4 or 5 problems on the quiz. And if you're not showing any work and you're getting the wrong answer, I cannot give you any partial credit for that. So you have to make sure that you're showing work. Okay? These numbers are very important. The work for those numbers are very important. And you'll be able to draw all over the picture if you need to. Okay? All right, so let's type those in. Now again, your answer might be a little bit different from mine because I'm using the exact answers. These are rounded answers, so I'll give you my exact answer and then maybe what yours would be if you rounded. Okay, so final answer here, 1131. So 1131.37. Now, if you rounded and used those numbers there, so exactly just what you see, I got 1,130 instead of 1,131. So, or if you're doing some rounding, 1130.97. Okay, which at this point is okay because of the fact that we are in such a crazy situation that you are close enough there. Okay. Okay, so this is where I would tell you to go ahead and pause the video for this example and try it on your own and just see how it goes. And then you can push play on the video to kind of watch to make sure that you did it correctly. Okay. So I'm going to go ahead and do it, but if you want to pause, you certainly can. So 1, 2, 3, 4, 5, 6 sides. So we're going to use 30 degrees as our angle. So this angle is 30 degrees. X for half of my side length, A for my apothem. The 4 is actually here. It's kind of hard when you're drawing that triangle in that the 4 kind of gets sucked into the triangle, but the 4 is actually the hypotenuse of this triangle. And because it's the hypotenuse, we got to use our sine and cosine. So sine of 30 degrees is going to give me opposite over hypotenuse. So that's going to be x over 4. And cosine of 30 is going to be a over 4. Okay, which when you went through and you did this problem, were you surprised that you got x to be 2, a nice pretty whole number? You might have been surprised, or you might have realized that this is a 30, 60, 90 right triangle. And if it's a 30, 60, 90 and the hypotenuse is 4, the short side is going to be half of that, which is 2, which means A would be 2 radical 3. Now you're not going to see that decimal here, you would see instead 3.46, but 3.46 is the same thing as 2 radical 3. So 3.46. Okay, then the three numbers you're going to multiply 2 times 3.46, and then multiply that times 6. Which final answer, 41.57. If I'm rounding that up. Okay. If I went kind of quick through that, you can always stop, rewind, and watch that again. Okay, last one. So I said kind of make sure you go back to this one if you haven't already, because this is, again, we had to make some changes based on kind of our new schedule here. So the other thing that you are going to see is you're going to see, I'm going to draw the best circle we can around this. And it's going to say, find the shaded area. Okay, so find the shaded area. Okay, this is, we were going over this with 11.2 where we were doing big minus small. And the big is just a circle, which we'll get to that in a second. But let's focus on the small one because that's what we've been doing for the last 2 problems here. So if I break this off, this is another hexagon. So hexagons have 30 degrees here. And then you need to find both x and a. And we're going to use sine and cosine to do that. Again, if you recognize that this is a 30, 60, 90, this short side is going to be 8, and it's going to be 8 radical 3 for the a. If you don't recognize that, it's not the end of the world. Let's just use sine and cosine. So it would look like this. Sine 30 is equal to x over 16. And cosine 30 is a over 16, okay, because you were given a radius. Now, don't go back to the homework and just think that every single problem is going to be sine and cosine, because remember, if you're not given the radius, then you're going to be using tangent. So whether you're given the apothem or a side length, you're going to use tangent. Radius is going to be a sine and cosine. Okay, so for this small shape, I need to find x and I need to find a. If I type this into my calculator, no surprises, x is 8. And a equals 8 radical 3, which is the decimal 13.86. Okay, so for the small part, we're going to take half the side length times the apothem times the number of sides. Okay, so I'll multiply my 13.86 times 8 times 6. So this is 665.11. Again, rounding. And again, if you don't have an answer that's exactly that answer, it's okay. You just have to be close to that answer. And by close, I mean within a few ones of it. So don't be within a few tens or a few hundreds. Like if you're 100 off, that's pretty far off. If you're at 162, that's close. 164 is obviously closer, right? So anything around there is fine. It's okay if you're over as well. Okay, especially because your work is going to back up where your numbers came from. So that is the most important. If you're off and you show no work, I don't know where you got your numbers from. So make sure you're showing your work. Okay, so then the big shape is a circle. Circles are pi radius squared. The radius of this circle is the same as the radius of the hexagon, which is 16. So this is pi 16 squared. So 16 squared, and then I'll go ahead and put the pi in my calculator to get a decimal. So that's 804.25, and then I'll subtract 665.11. And again, I'm using the exact numbers from my calculator and pulling those down to get an answer, which is 139.14. Okay, so going back to the actual 11.3 homework assignment. Okay, there's actually two parts of this. And so what we're going to do is we're just going to fill in the rest. Okay, so starting on this 11.3, we only did 3 of the problems. So now we're going to add in, go ahead and add in 14, 16, 17, and 19. Those are 2 given radius. Those are 2 given apophthegms. Okay, so those 4. And then also just continue on, because you really just need to practice this. So continue on here. These are all given the apophthegms on the bottom here. So 7, 8, and 9, those are all given apophthegms, but they're good practice. And then if you flip the page over, it kind of toggles back and forth between given apophthegm, given radius, given radius, given radius, given radius, but they're all different shapes. Okay, so just those 2 pages. What you'll find is that there's another 11.3. There's an 11.3 part 2, and you're going to find that video hanging out on Power School Learning, but that, as of right now, is not a requirement. So just up to this part, this would be an extension.